Hello again. I bet you didn't think you're going to see me so much today, but this is the next page after our types of compounds worksheet. And here we're going to use a different way to determine whether a bond between two atoms is ionic, polar covalent, or non-polar covalent. Now you may remember from the videos that a covalent bond is formed when electrons are shared. But sometimes electrons can be shared unequally, creating what's called a polar covalent bond. And if they are shared equally, it is going to form a non-polar covalent bond. And so we need to be able to decide what kind of bond exists between the atoms. And we're just going to use some simple subtraction in order to figure that out. Just to talk a little bit further about the difference between polar or non-polar covalent bonds, the difference is this. Suppose that you have a candy bar and you want to share that candy bar with a friend, but you don't want to share it equally because it's your favorite candy bar and you want a larger portion of it. So you're going to break off just a little piece of the candy bar, give it to your friend, and then you're going to keep the bigger side for yourself. That's like a polar covalent bond. Are you still sharing your candy bar? Yes. But did you share it equally? No. One of you got more candy than the other one. That's a polar covalent bond. In a polar covalent bond, the electrons are shared, but they spend more time around one atom than the other. In a non-polar covalent bond, the electrons are shared equally between two atoms. This would be like if you had a candy bar, you split it right down the middle, and you and your friend got an equal size of the candy bar to enjoy. So that's what a non-polar covalent bond is, when electrons are shared evenly between two atoms. So what we're going to do here is take a look at some of these compounds, and we want to see if what kind of bond they actually have. So here in the compound HBr, we have hydrogen and bromine. And so to figure out what kind of bond we have, we need to look at something called electronegativity values. The electronegativity values are found in this table here. So hydrogen is 2.1 and bromine is 2.8. So hydrogen, I'm just going to write that here, 2.1. Bromine is 2.8. And then it says electronegativity difference work here. So basically what we're going to do is put absolute value bars around this because the answer always has to be positive. So we have 2.1 minus 2.8, and what we get is 0.7. So when we take a look at the bond type, we just need to come down here, and the bond type 2.7, or I'm sorry, 0.7 is between 0.4 and 2.0. So that means that the bond between hydrogen and bromine is polar covalent. Now for our next compound, we have rubidium, which is Rb, and oxygen. And again, if we look down at our electronegativity values, Rb is 0.8 and oxygen is 3.5. So Rb, I'm just going to write it here. And to show our work, absolute value bars, we have 0.8 minus 3.5, and that's going to give us 2.7. And if we look back, if we look back down at our table, 2.7 is greater than or equal to 2. Therefore, the bond in between these two atoms is ionic. Now, I just wanted to make sure that you knew that, like, even though we have 2 rubidiums here, like, I'm not multiplying that by 2 or anything. It's just that you use 0.8 ones for rubidium and 3.5 ones for oxygen. All right, go ahead and use this pattern to fill in the rest of the table. Thanks, guys.